Well, so good morning, everybody. First of all, I would like to thank Professor Eduardo Cerqueira from UFPA, from here, from the Federal University of Uberlândia, my colleague here. And we are here today for the committee of the work by Vincent Richards. So I would like to invite Vincent to be on the stage to present. Okay, Vincent, good morning, good luck, and you have 40 minutes for a presentation, okay?
Okay, thanks. Good morning, I'm Vincent Richards, and I'll be presenting on an evaluation and analysis of computing virtualization on a Raspberry Pi using virtual machines. But first, I want to welcome Professor Flávio, my advisor, Professor Pedro, and Professor Eduardo. Thanks for being here, and thanks for this opportunity. So the overview of the work today, we'll be looking at the introduction of the work, of the research, and the background and literature review. Will be focused on single board computers, compute virtualization, network function virtualization, and the related work in this in these areas. And we'll know then, after which we'll look at the virtual machine on the edge, which is the core of the work, and our experimental approach to the evaluation of the tests. And then we'll look at the final conclusion after. So the introduction, what is the motivation of this work? Okay, so we want to verify, want to find out, is it possible to, first of all, run virtual machines on the Raspberry Pi, seeing it is not a traditional traditional computer, right? So we want to find out if it's possible to run it on single board computers, but mainly the Raspberry Pi. Next, if this is possible, we want to find out, we want to do an investigation on the capacity of the Raspberry Pi to handle computer virtualization based on VMs. So even if it can boot it, we want to find out, is it possible to run these VMs comfortably so that they can be feasible to implement. Then next, after being sure that these things are possible, we wanted to also use a mono entity that normally communicate with the Vim to deploy VNF across the whole infrastructure, both the traditional and the ARM infrastructure. Then finally, we wanted to satisfy the NFV requirement to have the capacity to deploy virtual machine, not only on the core traditional network, but everywhere, including the ARM architecture. So the objectives of this work and our challenges that we face that had to be overcome. So the objective was that we wanted to research, we wanted to verify which operating systems and which software components will be needed to enable virtual machines to run on both Raspberry Pi 3 and Raspberry Pi 4. Then we need to, our next objective, we need to find out, we need to perform tests with variables or metrics such as boot time, CPU, memory, and swap to verify the other capacity and compare the results. So we wanted to find out if the CPU performance, even if the virtual machines can run, how much CPU and memory is used that will allow it to be feasible to be used in terms of future works, in terms of works that can be implied for, say, in research. Persons can do it in research or industry. So next, we needed to investigate SBC's capacity, mainly Raspberry Pi 3, Raspberry Pi 4 to angle computing virtualization based on VM using an experimental approach. So we would experiment to find out the capacity on the Raspberry Pi 3 and also on the Raspberry Pi 4 to angle, say, compute virtualization comfortably. So compute virtualization would be similar to, say, the traditional system. We want to see how close it can perform to traditional system. And then we'd want to investigate state-of-the-art work that has been done in this era. Is there any work that has been done on using virtual machine and SBCs such as the Raspberry Pi? So we look at the background and literature review. So we're going to look at the single board computer, compute virtualization, just a background information, not much, like what is virtualization, VM-based virtualization, and container-based virtualization. And we'd like to look at a network function also, and the concepts relating to it, and the management and orchestration, and also related work in this area. So first of all, what is a single board computer, right? It's actually a computer just the same, though it's small. It's a computer that is built on a single circuit board. It has a processor, it has a memory input-output device, and it's able to function as a computer, normal traditional computer, maybe not as powerful, but it has the same functionality, right? Interesting things about it also is that it is low power in comparison to traditional computers, and it is low cost that will allow test beds, which has been a challenge in terms of the cost, has been a challenge to create infrastructures to use on the edge. So this will be a plus in this sense, and its ability to compete with general purpose CPUs, its ability to run similar softwares and programs as the traditional computer. So the SBC selection for this research is the Raspberry Pi. Because the Raspberry Pi has a huge community, so a lot more information will be available and help will be available in comparison to other SBC who that doesn't have such a large community, and require a lot more. It will have a lot more challenges in getting information and implementing certain things on it. So next we want to look at the compute virtualization. So just in a simple sense, it's an abstraction of computer resources such as operating system, networking, and storage, and such things. So we abstract it away from the underlying hardware. It's a type of hypervisor that we'll be using in order to run virtual machine. So there are various types. There are full virtualization, which will simulate the hardware and allow and modify guest OS to run in isolation from the host, which is one of the plus of using this on for edge computing in comparison to the container, which we will see further on. Just to note that there are different types. There are software-assisted full virtualization, and there are hardware-assisted full virtualization, where the hypervisor can talk directly to the hardware. And there are power virtualization, which in this there is no hardware simulation. The guest VM is aware that it has been virtualized. So there's also hybrid virtualization, which is a combination of both full and power virtualization. So for KVM is a type of hypervisor, and this is what we'll be using to get virtual machines to run on the Raspberry Pi. We can't use some of the traditional one that are used on say Intel, AMD, such as VirtualBox, but this Linux based is ideal for this case. So it's it allows virtualization, and it allows the VMs to achieve isolation from the host. So it's a Linux-based virtual machine, and it's used. It has to be used with emulation software or virtualizer such as QEMU. It cannot be used by itself alone because it's in the kernel, but of the operating system. So we need a user space emulator such as QEMU to use with it. So next we'll look at what is the VM-based virtualization. So VM, as you know, for virtual machine is an emulation of a computer system. So it actually emulates an entire computer system with the same architecture and functionality of the physical computer, right? It also is it's also considered an image because it's normally use an image for emulation. So it behaves like an actual computer and allows the creation of a computer within a computer. So it isolates from the host the software and hardware emulation. So it's a software inside a virtual machine. The softwares that are inside the virtual machine cannot escape or tamper with the host of the computer. Further on, we'll see the importance of this and why it's important to our work. So it actually protects the host computer from, say, a VM that would crash or be corrupted. So that would be a plus for this work. So next, there's container virtualization, container-based virtualization that is now mainly or widely used on the edge. So the container virtualizations are used in Linux is normally based on the first LXC, which is an OS level virtualization that allows all containers to share an OS kernel with each container, which allows it to be lighter and faster. But there are also a disadvantage which we'll see further on with this type of virtualization. So LXD will be a newer form of LXD will be a newer form of LXC, which makes things easier to manage and remove a lot of the complexity of managing containers. And Docker, it would be like a container with an overlay file system that is normally used for building and packaging applications that are portable, that is easy to be migrated. So knowing these two types of virtualization, so now we decide why would we want to use virtual machines. If it's possible to use at the edge, why would we want to use it? So there's a problem that even though there's these great features with containers, it's important and interesting features with containers, that it's lightweight and it's probably the first choice for edge computing because of this, and it have other advantages. But because containers can experience problems like a normal computer can, it can compromise the host system or even cause it to crash. So containers are great, but there can be challenges. So here's where we propose that virtual machines can be an option for those who are users who cannot afford to have their hosts experiencing any problem or crashing or losing information. So here is where virtual machines would be an option, where we're presenting it as an option because it's isolated from the host. So any problems with it, it won't affect the host, right? So network function virtualization, just looking at a few main concepts with it because it will be related in the motivation and the reason for this work also. So network function virtualization infrastructure is an similar to a low-cost, high-performance server, right? But then we need a VIM, a virtual machine manager, such as the OpenStack, to deploy virtual machines. And then we'd need to have a manner, it's an entity that is responsible for a virtual machine, for VNF management and orchestration. So it needs to communicate with NFV using the VIM. So it needs, for example, a virtual infrastructure manager such as OpenStack to communicate with NFV. So we would propose we'd want to use Mono with the virtual machines on the Raspberry Pi. So this is why we research adding Mono along in the research and NFVs, right? So we want to virtualize everything. The final one, we want to virtualize everything, because when it's virtualized, when everything is virtualized, it's easier when any error occurs to replace each component. So we're using a virtualize everything function here to make this possible. So management and orchestration, as mentioned before, virtual infrastructure manager, the VIM. This layer controls and manages the infrastructure entities. And then the Mono would be placed at the next level for handling the service management and orchestration of the middle tier. So the difference, we're going to look at related work and look at the difference with our work. Well, you won't be able to see much on this slide, but here the previous works are related works on the Raspberry Pi, because some use middle box on the edge, some use some of the research use laptops and traditional hardware. So those persons are researchers who used Raspberry Pi on the edge. Based on research, we notice these related work from here that they only use containers so far. So even if something exists, right, we're not seeing anything currently that uses the virtual machine, right? So it's the LXC, LXDR Dockers or Kubernetes that is currently being used. So it's the difference that we seek to bring, to use virtual machines on the Raspberry Pi as an edge device that will give an next option for those who need this type of security in terms of isolation from the host in case of any problems, right? So our difference to the related work is that we bring virtual machine. We are introducing it as an option on the Raspberry Pi, our SBC devices. So how do we get virtual machine to work on the edge device, such as the Raspberry Pi? So there have been challenges to get this done, because traditional computers use a certain method to implement virtualization. They use Intel VT and AMD to enable virtualization. And the Raspberry Pi, this is a challenge. The Raspberry Pi uses ARM. It does not use Intel or AMD, so it's impossible to use these extensions to enable virtualization. So how would we enable it? So I'll get back to this image. We'll look at the solution and then get back to it. So this actually explains the image, but I'll get back to it. So it's saying that the solution that we propose that we need to compile or build a kernel with KVM user space enabled, because we cannot use AMD nor Intel virtualization extensions. So we need to do this. If this or if it's possible, we can obtain a pre-compiled kernel with KVM user space enabled, right? So here you won't be able to see much, but the KVM need to be enabled inside a kernel, which is inside an operating system that is built for Raspberry Pi, right? After it's enabling it, we need to compile it. So this is how we enable virtualization on the Pi. And then we need to, it cannot be used inside the kernel by itself. It needs, in the user space, it needs an emulator, like QEMU, in order for it to work. So this is how it will be done to overcome the challenge of enabling virtualization on the Raspberry Pi. And then we need to have packages, software packages that will be needed to add and configure to allow it to create virtual machines and execute them smoothly. Right? So there are some specific packages that we need to install also. for that. So our test bed, we're going to be using Raspberry Pi 3 and Raspberry Pi 4. But the main features that will be of most importance here is the RAM. The RAM allows, say, for the Raspberry Pi 3, have 1 gig RAM. The challenge is that the less RAM you have is the less virtual machines that can be created, right? So the RAM is of great importance because it determines how much virtual machines can be created. So for the Raspberry Pi 3, we have 1 gig that we'll be using, and for Raspberry Pi 4, it's actually 1, 2, and 4 gigs, but we choose the 4 gig for the comparison. And also the CPU would make a difference. The CPU would determine the speed of the VMs also, and to an extent, the Wi-Fi can affect certain aspect of it also. So this is our test bed, the general settings that we'll be using in terms of the hardware device and their features. So we're going to be looking at our evaluation method, how we evaluate the data. So data gathering and analysis on a Raspberry Pi 3 and Raspberry Pi 4 will be executed each test 15 times to avoid statistical bias and calculate average values, which can be considered as a 95% confident interval, right? So we'll be running for the Raspberry Pi. We'll be running for each rounds, for each of the 15 rounds, we'll be booting 3 VMs consecutively. So we start at 1, then we go to the second one, and then the third one. So and see how it functions with running at the same time. Then for the Raspberry Pi 4, we'll do the same thing, but we're going to be using 14 VMs in this case for each round. And in each of these rounds, you'll be checking the CPU functionality, the RAM functionality, swap, the temperature, and the boot times, which we consider as very important for our assessment. The next, after we conduct the test, after the tests were conducted, we wanted to find out the experimental evaluation. We want to see, the functions in each area. So Raspberry Pi 4 average boot times for the first 6 VMs, which was observed to be lower than, significantly lower than the boot times on the Raspberry Pi 3. So even though 6 would probably be 3 times the amount of VMs that would be created on Raspberry Pi 3, but so okay, so even though it can be so even though it can boot a lot more VMs, right? The Raspberry Pi 4 can boot a lot more VMs. However, the boot times will increase over time, as you can see for Raspberry Pi 4. The boot times will increase significantly, especially for the last virtual machine, because it will be using it will be allocated less resources, right? So even though it can boot 14 VMs, that's 11 times more than the Raspberry Pi 3, but the 14 VM is not as efficient as we'd want it. So the best would be, I'd say, the 13 VM would be the best in terms of more efficient. For Raspberry Pi 3, the boot times were like an average, a little over a minute, right? Which is not really too bad, but for Raspberry Pi 4, it's less than a minute, especially for the first 6 VMs. So the Raspberry Pi 4 performance is better in the boot time era in that sense, right? So next we want to look at the temperature and the significance in this sense. So the temperature on the Raspberry Pi 4 behaves, behaves almost similar to the Raspberry Pi 3. temperature continuously rise during the VM's booting process for Raspberry Pi 3 for each VM. The temperature, it actually affects, it correlates with certain features, because it normally, just as traditional system, it would affect the CPU performance. So that's why we check the temperature to see the variations in the temperature, and probably if it's too high, if it may affect the CPU in this sense, right? So they are similar, or they are close in terms of behavior for Raspberry Pi 3 and Raspberry Pi 4, and don't seem to affect the CPU function that much. For the next resource usage would be the CPU. The CPU behavior is more or less the same in the rising during the booting process. So as each VM's virtual machines are started or booted, the CPU usage would spike, right? But during the non-boot process or period, for both Raspberry Pi 3 and Raspberry Pi 4, the CPU falls in terms of the usage is less, right? So when it's boot, it normally gives a spike because it uses more power, right? So it gives a spike in terms of the usage for both Raspberry Pi 3 and Raspberry Pi 4. So look at the RAM usage now. For Raspberry Pi 3, we use a 1 gig RAM, right? So it uses 1 gig RAM, and the maximum VM that is allowed on the 1 gig RAM is 3 VMs, which the minimum we could use, we could allocate for each VM was 256 megabytes RAM. That's because the image that we use require this amount. So we use the Ubuntu image that require this. There are other images that could use less, but we use Ubuntu in this case. So while Raspberry Pi 4, we use a 4 gig RAM, right? This allows a maximum of 14 VMs, which we use the same minimum amount of 256 megabytes RAM per VM, right? And so we're able to achieve these amounts. And they, as I said, boot and run, which we look for, because they were saying originally that these virtual machine cannot boot. There are persons who would see it as it doesn't make it's not feasible to run virtual machines, right, on the Raspberry Pi. But we proved that up to, say, 14, but even more so 13 VMs run efficiently and effectively, and with no crashes. There are no crashes in between or during. So we show that this is possible. It's not as first believed that it doesn't make any sense to use it on the Raspberry Pi. So the next thing we look at is the swap memory usage. Okay, when Raspberry Pi 3 uses 100% of the RAM, then we notice that the swap memory is now used to buffer the RAM, so to prevent crashes and smooth functioning of the virtual machine. So it brings the RAM into play when it reaches the swap into play when it reaches 100% of its usage of RAM. However, for the Raspberry Pi 4, I know there's a difference in how it uses the swap. The swap memory was used in the same. It was used during the first boot. It started to use it. It didn't wait till it's almost out of RAM. So it started using the swap memory along with the RAM in order to allocate memory for the virtual machines until 100% of the swap was used. However, the RAM memory was still available. There is still RAM memory available. So in conclusion, the work that we show that in our work, in this research, we show that the Raspberry Pi can be used for virtual machines and virtualization on the edge using virtual machines. So it's showing that I was taught before that it wasn't feasible. It is possible to use it on the edge, and possible to use it to add an option for virtualization on the edge instead of only having one option such as containers. So the next thing, virtual machines are, based on this research, we found that it's relevant and in some instances it's more secure to use, especially in critical situations that cannot risk host failure due to, like example, container failure that can affect the host in this sense. So virtual machines can be a relevant addition based on this research, an option to deploy compute nodes on low cost, low power SBC such as a Raspberry Pi. Based on the metrics that we assessed during the research, we see that the CPU wasn't 100% used in all instances, nor the memory in all instances, and the virtual machines were functioning efficiently. So based on this, we see that it can do carry out some functions as a compute node on the edge. The next is that the Raspberry Pi 3 is a significant starting point for edge devices using VMs, right? Because it can at least boot a certain amount of VMs, though minimal. But the Raspberry Pi 4 can offer significant more resource for scaling. So if you want more virtual machines, the Raspberry Pi 4 would especially Raspberry Pi 4 gig would allow that. All right. So our main contribution is that we have provided an alternative to the available options currently being used at the edge of the network, especially on resource-constrained devices such as the Raspberry Pi. So now persons can make a choice between when it's necessary then, or when it's important. They can make a choice in terms of using more, say, low-cost devices, because this knowledge proves that low-cost devices such as the Raspberry Pi can be used on the edge. So the next is that we demonstrate the feasibility and possibility of utilizing the Raspberry Pi on the edge as a low-cost and low energy consumption. So we show that it's feasible, right? It can be used for test bed. Developers can use it also. The infrastructure, the EDSIC compliant infrastructure for service deployment on the edge was also introduced to show that you know, we can do more than just running virtualization, right? We can connect certain components, NFVs and all of that with it. And with the article was written called Enabling Management and Orchestration of Virtual Network Function on the Edge. It was published in the 10th International Conference on Cloud Computing and Service Cloud Computing and Services. That's science at its closer, right? So for our future work, we're seeing that we can implement a solution that integrate the Mana, the Vim, and along with the Raspberry Pi infrastructure now that we are now putting in place that allows virtualization on the edge using virtual machines. Right, we can integrate them so that the Mana can have full control of the creation, deployment, and entire life cycle of virtual machines. We're looking at the possibility of deploying various applications in the future on virtual machines on the Raspberry Pi and to do tests to see how they function and how well it can, how feasible it is in this sense. So these are for our future work that we are proposing. So that's the end of our presentation, and I want to thank again Professor Flávio, Professor Pedro, Professor Eduardo for being here today. And if there's any question or suggestions, they'll be welcome.
Okay, Vincent, thank you. Well, so now to continue that, I would like to invite Professor Eduardo Cerqueira from the Federal University of Pará to make his comments and to make questions for you. So, Eduardo, once again, welcome and thank you for being here with us today.
Thank you very much, Flávio. Thank you for the invitation. Thank you, Vincent, for the presentation. And hello again, Pedro. So I will try to give some comments and give my view about the dissertation, about the subject. First of all, virtualization is very important. It's still a hot topic. Edge computing is also a hot topic, and it was well motivated at the beginning of the dissertation. And as you can see, you said that it's very important to have edge computing to reduce latency and things like that. So it's clear. Regarding the presentation, I think that you should use, for example, Grammarly. It's a kind of tool that will help us with the English, etc. There are some typos. We need to have some work with some paragraphs, pictures, structure, etc. But we can talk about it later. It's not. I will not discuss point to point right now. Okay. Let's go to the main focus of the thesis. Again, for me, the dissertation is important because we can better understand the performance of Raspberry Pi running cloud virtual machine service. And you gave for the community a good piece of work, so we can use your work to understand better and see what we can do and what we cannot do if you want to use Raspberry Pi or another similar unit to provide some service for IoT or for some application, whatever. So at that point, it's cool. And you also have some testbed results that is really good again. And it's important that you already published a paper. So not only Eduardo, but the entire community said that you have a research work. So it's really important. But now, what I will start to talk basically will be some ideas to improve your work. Not necessarily this work, the current work, but maybe can give you some ideas for future work. First of all, I think that it's really important to discuss why do we need Raspberry Pi running edge service? In what kind of scenario, for what kind of use case? Just a second, because I need to switch between words. In what kind of scenario, what kind of use case? For example, when we say that edge compute is good, it's good because it will reduce the latency. And maybe we need to think about reliability. We need to think about some performance metrics. And maybe Raspberry Pi could not be a general solution, good for everybody, for all business, but maybe for a specific business model, specific scenarios. For example, in a farm, isolated area, or for non-mission critical application, etc. Because as we said, you have some issues that must not be solved when you are using Raspberry Pi, for example, power, energy, whatever. So in that case, you should make clear for what kind of application or applications or for what kind of scenarios, what you are proposing is really good, and maybe what kind and when it could not be so good. So, because when we read your thesis, we believe that everyone could implement a Raspberry Pi solution and it will be good for edge computing. So, maybe it's not it's not true or 100% true. So, if you could go deep in that, maybe you can use it in drones. So, UAVs that will be triggered to do some work in a specific for a specific mission for a couple of hours, and maybe in this case it's good because it's light, it will provide enough energy to run a specific service or piece of service or small service, whatever. Another question is, why do we need to virtualize like small board units? Why we need to virtualize? What kind of, again, scenarios, use case, whatever, we need to virtualize a Raspberry? Maybe it will run 2, 3, 4, or 20 servers on the same time. So maybe you can give more attention in questions like that. If you go in this direction, maybe you could say what kind of application, maybe ultra-low latency application could be good for Raspberry Pi testbed. For example, you said in some part of the documents that virtual reality is good, or it's a key application for edge computing, but are you sure that you can run some virtual application, virtual reality service in a Raspberry Pi? Or maybe it will be good to run what kind of low or ultra-low latency applications? Another issue is that how can I know that it's not the time, or maybe it's not the focus of the master, but you should go deep into the container part, or what kind of software will run, or how to instantiate something. I know that it's somehow in the future work, because like you are going to deal with the entire life cycle of the scheme. But anyway, maybe you could talk a little bit about that. What can I run, when, how, for how long?
Okay. Yeah.
When you see something about IoT, small device, small computer, etc., we are worried also about energy, because like is that you can have, for example, a solar panel or an external battery that will provide some kind of energy for a certain period of time. So maybe you already have the test bed, you already have this information, and you could collect it. Maybe you have some kind of software that can measure the energy consumption, etc. You can just plot, you can just present this information in the final document. Another thing that, for example, when you have like Raspberry, BeagleBone, Arduino, etc., we know that it's a kind of it's not a final product. It's not a brand name. I mean, it's not like a Cisco, IBM, or whatever. So it could be interesting if you can run an experiment for an hour, a day, a week, a month. I know that it's difficult to run right now, and maybe it will not be part of your final document, but it would be good for the community to understand something about reliability, or even we can think about resiliency. What can we do after one day because the performance is too low, or the unity board will die, like that. When you are running the experiment for minutes, that's fine. Probably you are not going to have this kind of issue, but maybe 1 hour, 1 day. Let's see.
Okay, thanks for your contribution. I'll note them.
I still have some other discussion that we can talk about. Again, could be really nice if you can collect results about latency. Because like without this information, it's difficult to motivate the use of Raspberry Pi as a edge computer, server, node, whatever. So if you don't have latency, it's difficult to link. You can say that it's a additional service that can run, but maybe it's not the best time to say it's an edge computer service. It could be good if you run if you have some information about the control plane and data plane. You already have information about the control plane. Maybe you say second, time, etc. But about the data plane, maybe you can run some application and real application or whatever and collect some results. It's good because we already have the test bed. The most difficult part is already there. Additional comments are something like, based on your experience, can you optimize the operational system, the software, the code to best fit in a Raspberry device? For example, I will not install all modules, or I need to optimize this part of the code because it's not necessary for like a Raspberry or small unit board.
So you're saying if I could optimize, say, something that is running on a Raspberry Pi to run on a traditional computer?
Yes, for example, you have Ubuntu running on the Raspberry Pi.
Yeah.
You could optimize even better the Ubuntu to have a better performance.
Okay.
I will not have this library or this model
or... okay, I understand. You probably could, but you'd have to probably recompile the operating system. So we can actually rebuild the operating systems, right?
Yeah.
But some are more challenging than some, but you can rebuild it and remove unnecessary packages.
Yeah.
Where possible. Yeah, so you could probably like a minimum system you're targeting, so it could be lighter, faster, and all that, right? In that sense. Yeah. So yeah, it's possible to recompile it and rebuild it for it to be more efficient. Yeah, it's possible.
It's cool. Like what I'm talking about is that it's not only your master defense, but you have a very good piece of document that can be available for the lab, for the community, etc. And at least they can have some ideas for future work they can do. For example, our next student can and have your work and then extend it with some ideas.
Yeah.
And according, follow the same idea. For example, it could be good to show again what kind of scenario or use case we should have, like 10 virtual machines, 14, 20, 2 or 5, because at the end of the day, one conclusion could be, okay, Raspberry Pi can run up to 14 or 15 virtual machine, but it's better to run just one single application, whatever, because like we can deliver the minimal quality of service requirements for application with one single virtual machine, something like that.
Yeah, we're looking at testing them. That's we're thinking about in future, probably because of the time. We're saying in the future work, we could test the application and how much VMs possible will be able to run if we are running applications. And for
like if you present how many virtual machine can we run? But you do not present, like I will say, quality of service performance or requirement. Maybe with the virtual machine, all of the application will have a better performance. So it will not be good for all of the applications run on the top of the virtual machine. Divide like the data plane and control plane.
Okay. So it's a good idea. I could look into it for future work, for to write more about it for future work. So it's good. Yeah. Yes, so thanks for your contribution, your suggestions. Appreciate it.
Thank you. Okay, just my operational system is just trying to update something, so I'm not sure if the call will work well in a few minutes, but anyway. Professor Flávio, basically this is, I think that I gave my contribution, that's all. So we still can have a talk offline if needed. But anyway, thank you very much again, and congratulations for the work.
Okay, thanks much. I appreciate it.
Flávio, we are not hearing you.
Oh. Can you hear me now? Oh, yeah. Great. Well, so Eduardo, thank you for your comments for your suggestions. We really welcome them. And now I would like to invite Pedro, my colleague here from the Federal University of Uberlândia, to join us and to make the comments. Please, Pedro. Thanks again.
Thank you, Flávio. Thank you, Richard.
Thanks.
I would like to thank you, Flávio, for the invitation to participate in this work. Likewise, I extend my thanks to Richard to the invitation. It's a pleasure to participate in the completion of Professor Flávio's work and to share this moment with Professor Eduardo Cerqueira. After the brilliant comments of Professor Cerqueira, I have some comments, and I have not many questions posed because Cerqueira had made a lot of questions, interesting questions. So I will not repeat this question. The work has some typos, some sentences that deserve to be reviewed. I agree with Professor Cerqueira. But this is not the text I sent by mail. I do not think it's the case to stand in this matter. I have a first question to Richard. Did you evaluate what other small hardware could be used as SBC?
Yes, I look at them, but I didn't. I wasn't able to do tests on them. Right? There are some more in terms of some more ARM devices that could have the potential, but in terms of that is in the same cost range. We're not talking extreme like the servers, ARM servers that have a lot of memory and power. For SBCs, like similar to Raspberry Pi, look at them, but there could be challenges in the sense that in most of those devices, the community that support those devices, they have not put out. I've not seen any work out there in terms of trying to do this. It's actually just mainly the Raspberry Pi that has been getting this attention. So that could be a challenge. If there is not a lot of support, it could be a challenge to use it. But it's a good idea to check, but probably time frame would be a challenge. So there were parameters or reasons why we choose the Raspberry Pi 3 in that sense. But there are others that are coming on the stream that I think could, but because they are relatively new, they have not been explored as yet. Yeah.
Okay. I mentioned SBC, and I remember that in your work you posed some acronyms before the meaning of the acronym. You did the review in the work. About energy consumption, I think the question of Professor Cerqueira is very good.
Yeah.
It was important if you drop some lines about the energy consumption, because when we mentioned to work on the edge, what kind of sources could be the source of energy for this kind of device? So, for example, solar, and so on.
Oh, yeah, I can understand. You're saying it could mention that we could use these energies on the device.
Yes. Because Cerqueira mentioned it properly. For example, a farm drawn, so the consumption of energy is important in these scenarios. So I believe it's fine if you drop some lines about this. So I have a last consideration about your references in our bibliography. You reference the article from 2011 to 2020. And this space is very good. This seems appropriate, given the nature of your work. In 2016, you referenced 10 articles. And in 2018, you referenced 17 articles. So the peak of references in these 2 years, 2016, 2018. In 2019, last year, you referenced 5 articles. And this year, we are in the end of the year, you referenced the 3 articles. It seemed that was a decrease, perhaps a lack of interest after 2018. Could you explain?
I think there's a possibility of some changes in the direction. Yes, probably as you are saying, if it's interest. I guess if they probably were researching and they didn't see the feasibility, or they didn't see it as possible for this to work. Probably that was one of the reasons. But to generate more interest, I guess then we bring something new like this, hopefully to generate more interest.
Okay.
So it could be, yes, it could be that, I don't know, sometimes I guess if they are not motivated to use this technology, it can reduce the interest. If somebody is using it or it's being used more, it can generate more interest. Yeah. It's possible.
I said the Professor Cerqueira is a hot topic.
Yeah.
So this year, okay, I do not expect so many references while writing your work, trying to wrap the ribbon. But last year, 2019, I would expect more references. Maybe you can.
I think probably, as I was saying, the thing is that they were mainly focusing on containers. So I'm wondering if that have an impact. Probably they think it's exhausted. So by showing them that there is something else that they can use, and the reason for it, the benefits, probably to generate more interest. But I think interest is there because 5G, it's an enabler for 5G, right? So edge computing is one of the enablers. So I don't think it will die. I think it's needed because 5G is just beginning to be implemented in certain areas. So it will be very interesting just the same.
Yeah, because while reading our work, the literature, wow, it's an updated work. Okay, that's my work. So, thank you once again, Flávio, and to you, Richard, to invite me to this participation. Thank you.
And thanks for your comments and your contribution also.
Thank you.
Okay, Pedro, thanks for your comments. This work, main motivation, Vincent explained that. It's regarding the idea of having a common set of virtual networking functions that you can deploy seamless, no matter you are on low resource devices or servers. And by the way, make the management of that seamless. So this is part of a work that you're investigating, and I mean, Vincent had to learn a lot of new concepts during his work. I think that is an important point that you should also, I would like to highlight, because he had to get in touch with a lot of concepts, and he's really a hard worker. So that's important. As long as you have challenges, and if you have the strength to go forward, then you can beat that. And so Vincent is from Jamaica, and he comes here from a program that our university has. So we have students from Latin American and Caribbean, and then they sometimes come to Brazil, and now he's here with us. And I think that during this time, he could have get in touch with several concepts. One important thing is that I think that we had to mention is that the part of the goal was to have the VIN managing the VMs. So that's part of what we did in the work, but this is an ongoing work that we're looking for it. So but we would like to investigate that. The first point is how does the PI can support the VMs? How much does it cost for the memory and the support? And so Vincent had a lot of different challenges, but he's always here in the lab, working, researching, and I think that was a very nice moment. In fact, part of what we're doing, we're planning a further publication of what he's doing at this moment. So we are ongoing on that. And one of our point or research questions that we still have is that regarding the support of applications, how the applications will perform. Because we face just like the basic stuff, deploy the VMs, as long as with the VNFs. Now we want to investigate how they will perform, and then taking into consideration other parameters, as Eduardo said, and also quality of service and experience and things like that, some metrics to have that. Well, I really welcome you guys for the comments and for being here, right? And I would not like to give no more comments on that, but I really thank you, the comments. We will check the work. This grammar review, as I said, was not our first goal, but that will be our next one, to check that, like the final version of the work. So I really like to thank you for that. And to continue now, I would like to ask Vincent to leave the room